teaching plan. So, student, okay. Let me share my screen. Okay. Let me check whether can you see it or not. Okay, should be okay lah, nah? So let me turn on this one. So currently we are 30th of December, almost to the New Year Eve. So it should be finished this one. We finished this one already. Then for 30 should be here lah. We should be in here. Oh, I should release the PBL today. This week, not today. This week. So I'll release it soon. Um, okay, by right, we need to continue the pitch factor, distribution factor, and winding factor, which I already covered during last lecture. And some of the notes I still not yet come out the example lah. Please remind me. I hutang you for the pitch factor, distribution factor, and the winding factor. I need to do something of the example in the mathematics and also graphic, or else we cannot get it. What is the pitch factor? What is the distribution factor? What is the winding factor? And don't worry about this derivation. Actually, this pitch factor, distribution factor, and the winding factors we need to derive ourselves based on the number of slot and number of stator and the number of slot via PM machine. So I don't think that the slide that we share or the slide that you have is enough for you to derive. In fact, I think that you no need to know how to derive for current state, but you just need to know go through. We will say go through what is the pitch factor, what is the distribution factor, and then agak-agak know roughly how the equation can come out. In the final exam, the equation will be given. You just need to know how to apply. Okay, because a different motors will have a different equation. Maybe some motor having the same pitch factor and distribution factor, but some are not. So today we will go to the transformer design, and then lastly will be induction machine design. I think we will go to the transformer design first. So we are 1 week ahead from the topics, which is good. Hopefully it won't burden you. Some of the topics is important, some of the topics are not important. In fact, just for you, just to let you know briefly about that. So, well, let me close this one. Where we stopped last week, pitch factor, right? Exam slide. Pitch factor. Oh yeah. I think we already. This one I need to find out some of the derivation equation. Later on, this one I'll put it a little bit later. So we will go to the transformer design. Let me check. There's okay, transformer design. Can you see my screen?
Yes.
Can I? Thank you. Okay. In a transformer design, it's not like a PM machine where we need to design all the dimension by using the so-called very basic equation from scratch to become something. No, it is not. For this transformer design, it's not only used to design the big transformer or like your adapter transformer. No, it is not. But in fact, it is also included the rectifier. So usually like our phone charger, let's say like iPhone charger, it's only one box, right? Then inside the wall plug, or inside the wall plug, it has the transformer, it has the rectifier, it has everything. And then what is the topic cover here is we need to know what type of a rectifier we are using, and then according to the type of the transformer we want to design, for example, delta to delta, Y to Y, and then what is the topology of the arrangement of the steel, how the coiling, what is the window factor, everything by using the equation that already have. that already have. Usually lah, this topic in the final exam, uh, all equation are given. All equation are given. But this time, I think this topic is not covered in the final exam, but instead put it in a BBL. So what you need to do is you need to find something information here to do the calculation. Yeah. So let's have a look. I think transformer. I believe lah. You guys are very familiar with the transformer in EET 4 EET 208, the electrical uh, power technology. And in the transformer of electrical power technology, we study about the short circuit test, no load test, open circuit test, whereby we transform, we change the physical transformer, this one, to large signal. Large signals, maybe something like, if you still remember, it become like this. Uh, we, we change everything from here to here. So this is a primary side, this is a secondary side, where refer to the primary side. Or this is a secondary side, the primary refer to the secondary side. If you still remember, we call that, we study this one under large signal. So in here, in this topic, we are no longer use this one because we don't want to know what is the parameter or the parameter inside of this the so-called like equivalent resistance, equivalent reactance, magnetizing resistance or magnetizing reactance. No more, no longer important for us. However, it is important for us is the geometry. So a transformer is a static piece of equipment used for raising the or lowering. I think I won't go this one. You will just go through it. And then primary winding, AC source is connected to this winding. Secondary source is load is connected to this winding. So primary, secondary, this one will be connected to the load. And then AC transformer must operate in AC. It cannot operate in DC. Cannot operate in DC. So working principle, very simple. I guess you already know that when we use a V2 divided by V1, our turns will be N2 divided by N1. That's it. So the polling point may be noted carefully. The transformer action is based on the law of the electromagnetism induction. This law, whereby E equals to negative d phi dt. When there's a changes of the flux, which means change from maybe 10 Weber to 11 Weber to 12 Weber. This one, when there's a changes, then there will be induced EMF. There's no electrical connection between primary and secondary, so we call isolation. Isolate it. No, because of no electrical connection. There's no change in frequency. If let's say the good one, when frequency F is a 50 hertz, out must be 50 hertz. So the good transformer. And then the losses occur is a copper losses and copper losses. This one will be, if let's say we study in the electrical itu panggil apa? Electrical power technology. Okay, we have okay, this is RC, this is X, and this is the R equivalent, this is X equivalent. So the core losses are from here. Okay, copper losses is from here. Core losses is eddy current and hysteresis losses. Copper losses is I square R. In practice, these losses are very small, so the output power is nearly equal to the input power. So if let's say we don't want to focus in the losses, then let's say this one is a 10 watt input, output should be 10 watt. So transformer, what type we have? We have usually like we have like our battery charger. We have a 230 VAC. Then when you have a look on the adapter, it was stated that okay, the output is 5 volt, and then 2.1 amp. Recently I bought the Penang, Penang, kita panggil apa? Power bank. I bought a power bank. It found that output is 5 volt, 2.4 amp, something like this. This is the output. So they need to have a step up and step down transformer lah. For the phone charger, it is step down lah because we are using 230 VAC from the power outlet PNB and then step down into some AC value, then it will rectify become 5 volt. So this step dia tak include, tapi dia ada apa? They did let us know what is the output of 5 volt. We have a 5 volt, we have a 12 volt, we have a 9 volt, something like this. Then step down transformer, single phase, a three phase transformer, whereby when we already know the basic of the step up or step down transformer, we can choose either we want to have a single phase or three phase. ET 208 already taught. Then we have a power transformer where this is more to the higher rating, and then distribution transformer also higher rating. Then another one is instrument transformer. Instrument transformer is used to do measurement. Like the current transformer we call CT, potential transformer we call PT. Current transformer is something like um, we step down the current, and then potential transformer is step down the voltage. So I think instrument transformer has been discussed more in power system relay code, if not system, not in this chapter lah. So instrument transformer used in the AC system for measurement electrical quantity, like the current, voltage, power, energy, power factor, and frequency, used to do the measurement. So the rating will be very small. Rating will be very small. Instrument transformer also used with the protective relay for protection of the power system. Basic function of instrument transformer is to step down the AC system voltage and the current. For example, the high bus, the main bus system, it is at 11 kV. Then we want to put it in a measurement to show what is the value. So what we need to do is we need to couple the transformer whereby this is 11 kV, then it step down into maybe 12 volt, something like this. Then we change the 12 volt into the display to show it is 11 kV. So this is the basic function of instrument transformer. Like we only use to step down. We don't use step up. So the voltage and the current level of power system is very high. It's very difficult and costly to design a measuring instrument for measurement of such high level. So general measurement instruments are designed to 5 amp and 110 volt. We have two types. One is CT, one is PT. So instrument transformer, this one we need to see. Differences. So have a look on the differences for the CT transformer. I think this one is not that important. Important important aspect. So I will bring through bring through it, but you need to study lah, even though final exam this time is not come up. So current transformer is connected in series with the power circuit. Potential transformer is connected in parallel. If let's say some of you have gone through the internship in a consultancy, I believe that you are very good in SLD, single line diagram, or I think recently you have ATP, right? ATP also use a current transformer and a potential transformer. So usually they will come out like the rating is either 5 VA or 10 VA. This is the rating. And then the connection current, it must be series. Series means it must be connected to the line. For example, we have a 3 line. When we want to measure the potential voltage transformer, we set a winding here, and then it will convert into another voltage. For example, this is 11 kV. So the winding here will be more. Let's say this is 100 turns, then we have a 10 turns. So this, when the turns is reduced, the voltage will be increased, right? So maybe I give more. So when the turns higher, then the voltage will be reduced. So that it won't give me 11 kV, it might give me 1.1 voltage, something like this. This is for potential. But if let's say for current transformer, it must be connected like this. So this one must be connect to another coil. It must connect to the line in series with the power circuit. So potential transformer, secondary is connected to the voltmeter. So this one will be connected to the voltmeter. Secondary works almost in open circuited condition, whereby open circuited means there's no load, means its current is zero. No current passing through, or very small current passing through. Why? Because it must have a very high resistance, because so that I can measure all the voltage here. Yeah, V equal to IR. When I is very small, R must be very high so that I can measure the voltage. And then primary current depends on the secondary burden. Primary current is this one. And then primary current excitation variation received to small range. One terminal of secondary can be earth for safety. One of it is earth. And then secondary can be used in open circuit condition. That's why when we talk about open circuit means I equals to zero. Okay. Then secondary is connected to ammeter. So this one will be connected to ammeter. Secondary almost short circuit. Why we short circuit? Because we don't want to have a voltage drop, which is I squared R. We don't want to have a voltage drop. I mean IR IR voltage drop. And then primary current depends on the power circuit current. Primary current excitation vary over. One terminal is earth. Then secondary was never be open circuited. Never, because inside got current. If let's say here current is 100 amp, okay, so this one will be 100 amp as well. Cannot open circuit. Advantages: the last voltage and current measure using a small. I think this one go back to study. Go back to study. Step up, step down, very easy. Let's say we have a 110, then we can have a 220 or 240. This is step up. If let's say we have 220, we can step down to 110. Just change the primary or secondary. Right? Step up transformer, I won't explain this one. I think this one you already know in EV208. Same as well. Just that I need to highlight here. When we talk about three-phase transformer, please draw as a black box. We see from the black box first. Baru go inside to see this one. So we have a high 1, high 2, high 3, x1, x2, x3. We can draw like this, or we can draw like this. Usually in the nameplate of transformer we use EX. It is drawn like this. And then this one is delta and delta. So as you wish, P1, primary 1, S1 is here. As you wish. If let's say you want to put here, then S1 will be here. Or you want to put your S1 is here also can. No problem, because it is a black box. And when we talk about three-phase system, we are more interested in the line-to-line instead of the phase. If let's say for the single-phase transformer, it's very easy, like this. Everything I say is easy. We just also see we also see as a black box, and then but the line is equal to the phase. The line is equal to the phase. But here, if delta to delta, line is equal to the phase. If let's say y, the line will not equal to the phase. So that's why we firstly, when we want to read the three-phase transformer, please put it as a black box. And then we know where is the primary, where is the secondary, that is, and so on. Power transformer, generally used in transmission network for stepping up or down, for example, from 33 kV to 11 kV. Then we need to use this one. Okay. Sometimes we do have a 330 kV to 11 kV. Also have. Yeah, if let's say you come across a cooling method, right? Yeah, from the test, a lot of people not very good in the cooling method of transformer, lah. And that's the only assessment. After that, no more. Yeah. So this is the oil and also a radiator, and also they have a fan, something like this, and this is the oil tank, right? Same as well. We have a fan, radiator, and then oil inside. Okay. Distribution transformer. Oh, step down the voltage for distribution purpose. For example, we have a 11 kV, then we distribute to become 400 volt, right? 400 volt. From this slide onwards, this one we need to know. We need to know in order to do the PBL, your problem-based learning, on how to design the transformer. From the feedback of the student that it's good that we need to discuss about the question, right? Actually, in fact, I'm waiting you guys to ask me. What I have here is I give you the answer. Now I already give you final answer, but the solution, I I cannot directly give you in on how to solve it. Some of the topic only lah, some of the topic, and then some of the topic yes. For example, this transformer design, I think I have one. I forgot to upload the tutorial for you. There's a tutorial question and answer lah given there. So what you need to do is you need to refer to the tutorial and then see how they answer by using the equation you have in these notes. And then that type of the question is only suit for uh, uh, one of the so-called type of the transformer. So in the end, it cannot be used for everything. Cannot be used. I would say cannot be used for everything, but the topology are there, the methodology are there. Maybe you just need to. I mean, maybe we just need to use back the equation, change the value, and then do the calculation again. Something is like this, something. Then some of that it is not according to the answer, but you can find the equation in these notes. So for the type of the transformer, we have a core and a shaft type. uh, Core type is like this, shaft type is like this. Then the core type transformer has a two vertical legs and then or limbs with two horizontal section limb yoke. This is called yoke lah, yoke. Core is rectangular in shape with a common magnetic shape circuit. Cylindrical coil. High voltage and low voltage are placed on both limbs. So for the core type, maybe the blue color we call as a low voltage. Yeah, blue color is low voltage winding, and then outside one will be high voltage winding. So the high voltage will be outside. So for the shell type, this is low voltage, this is high voltage. Shelter transfer has a central limb and two outer limb. Both HV and LV coil are placed on the center limb. Double magnetic circuit is presented. Double magnetic circuit means it will have a one like this, and then Barry type transformer, the core looks like spoke of the wheel. Spoke of the wheel. Spoke of the wheel. Spoke of this is called spoke. So for example, our wheel, our car wheel, right? Then in order to take over this wheel, we have a bussy inside here. This one is called spoke. We call shaft lah. Tightly fitted metal sheet tanks are used for housing this type of transformer with transformer oil filled inside. So actually, in the end, we have two types of transformer lah. One is a core type, one is shaft type. How's the arrangement of the transformer? And then we have a barrel shaped type transformer shown. This is so-called the barrel shaped type lah. Maybe it's quite difficult to visualize it, or you can try to Google image it. Try to Google image it. Transformer specification requirement from end user. For example, Apple saying that I wish to have a transformer where the input voltage is 208, output voltage is 28 volt, so that I can charge my battery, my handphone, for example. Then the output current maximum is 10 ampere. And then maybe like something like this. This is a transfer specification requirement from the end user. After that, engineer maybe need to know what is the type of the bridge we need to have for the output circuit. It must be full bridge. What is the input and output? So for example, in this case, it's a delta. So delta connect to the delta. This is a three-phase transformer. And then we need to connect to a full bridge rectifier. Full bridge rectifier, we usually draw like this. Full bridge rectifier. So this is delta to delta. Then will be connected to the load, whereby the input is a 208 3 wire, then output here will be 28, then with a 10 ampere. After that, 50 hertz. Efficiency is a 95 percentage, which means let's say I have 100 watt input, output I will get 95 watt. Okay. Then regulation 5%. This one is using your EET 208 knowledge. If let's say you still remember the, what is that? VR, voltage regulation. So this is the one. Then what is the flux density we have? It's about 1.4 Tesla. And then magnetic material. So for example, what is the magnetic material? The material that we use to do for the to construct the transformer. And then the window utilization. This is so-called window utilization. How good we use this one to coil the winding. For example, this one. How good we use to coil the winding. These two. Okay. After that, watt per kilogram is the density, power density. Power density means we use watt divided by kilogram. So this is the things that we need to have before we start the computation. And basic concept of design. What is meant by electrical machine design? Design may be defined as a creative physical, no, nothing. The basic design of electrical machine involves the dimensioning of the magnetic circuit. Well, I don't think this is very important. Let's just have a look on that. Then electrical designer must be familiar with what? When you go out to the industry, if let's say you are in transformer design or consultancy, maybe we need to catch up some of the standard here lah. Last time we have an India standard, Bureau of Indian Standard, India British Standard. This is last time we widely used lah. Then IEC, National, NEMA. For the machine design, we use this one, the National Electrical Manufacturer Association. It is usually for industrial motor design. For the IEC, a lot of the electrical installation. For example, recently Malaysia, they use IEC 60325. Inside a lot of the standard means a lot of wording we need to see before we and then apply in the consultancy design or SLD, singular diagram. And then specification, we need to know what is the cost and the material and the labor, manufacturing constraint. Major consideration to deploy a design. The design should be carried out based on the given spec using available material economically. So usually the spec will be must be lower cost, higher durability, conform with the performance criteria as laid down in the specification. Factors for consideration in electrical machine design: magnetic circuit, for the flux path, electrical circuit, insulation, cooling, machine part. All of this, no matter is electrical machine, I mean the motor or generator, also cover transformer. Yeah, these three is actually electrical machine, even though transformer has no rotating. And then the limitation, for example, why we want to do the mini project of designing the electrical motor? We want to avoid the saturation. What is the temperature rise? How good is the insulation? How good is the mechanical strength? How good is the motor and customer specification? This is all the limitation. Well, actually, we did put in the machine the analytical calculation last time when we taught in the chapter 1, right? Chapter 1. Some previous few chapters. Commutation for DC motor, power factor, standard specification. The basic structure, we have a magnetic circuit depending on the core, yoke, air gap. We have electric circuit, we have a dielectric circuit, thermal circuit, and mechanical parts. All of these need to be considered But currently, we still not yet consider everything in the mini project, especially the thermal circuit. We did consider dielectric. We did consider this one. We did consider this one as an analytical calculation, right? The basic motor sizing calculation. Motor sizing calculation. We did put it there. And then how the winding, we also put it there. Dielectric mu, yes. And then thermal circuit, not yet. Mechanical part, dimension only, dimension. Transformer design side view. This is just slanting it, slanting it. For example, the core type. When we see from the top, I think from the top view is here. This is a side view. Then it is coiled here, right? Then for the another one, it will coil like this. Okay. So transformer design cutaway. Nothing here. So this is all the equation you need to use later on. The area product AP of the core is the product of the available winding window area WA. WA will be given in the database. This one, this one. WA, yeah, this one. This is WA. Will be given. This is design and dimension data. In the end, what we need to do is we need to pick up what is the value to be used later on in your project based learning. So for three-phase transformer, because there are basically two window area, so use this equation. I cannot tell you how the equation to be derived. Basically, I just take it from the book. And then the area product. After that, if let's say single phase, use this one. If let's say three-phase, use this one. Then why this core geometry value is so important? Why this core geometry is very important? Have a look. An engineer will know the design and dimension data for the lamination. Okay, lamination. We have a EI type, EI. Then we have a EE type. Okay, we have a F. Okay, F type. We also have a UI. We have a LL. Then we have a DU type. Okay. Then yeah, depend on the different of the equation type of transformer lah. And then if you familiar with the transformer in the adapter, when you take it break it out, it's something like this. And then different core arrangement with the part number, then all of the D, E, F, W, A, C, and G can be found in this table. So we have other part as well. Okay, example. Oh, finish already for the transformer. I think I need to go into the tutorial. So just now, not tutorial, the example. Just later we will go to the example. What time now? Almost 3:48. This is one more another type of a specification. So very thank you for giving me feedback on how to make it effective for the computation. So your problem-based learning will give you this type of the question. Then we need to design all the find out all the parameters. No discussion for the example 1 and 2, but I will just discuss directly through the tutorial. So let me have a look. What is a good stuff? Maybe can we stop here, rest for 10 minutes? Then I come back again. Is it okay? We come back with this tutorial solution. Is it okay? Didot semua.